Imagine being able to troubleshoot your network in just a few clicks. No more hours wasted digging through device configurations and logs. NetFabric makes this a reality. I'm Clemens, software engineer at NetFabric, and in this demo, I'll show you how NetFabric detects and pinpoints misconfigured access control lists, enabling you to resolve network issues faster than ever. At NetFabric, we are building an intelligence engine for networks with 5 key focus areas: get visibility, prioritize, connect, predict, and innovate, all to help you save time. Our demo today exemplifies how NetFabric allows you to get a deep understanding of your packet trajectories by connecting flow observations, routing models, and ACL behaviors, so you're not wasting time on collecting individual facts before understanding the whole problem. Before we dive into an example, let's understand what access control lists are. Access control lists, or short ACLs, play a crucial role in modern networks by controlling which traffic is allowed or denied on network devices, ensuring security and traffic management. But with evolving networks, misconfigurations can occur due to complex relationships of thousands of rules, leading to unexpected connectivity issues. Resolving these manually is error-prone and time-consuming. With this knowledge, let's look at an example. John, one of our customers, has reported that their new internal service API is unreachable from their backend production server. They have already attempted to ping the server unsuccessfully, indicating that the issue may be network related. The L1 support already resolved the host names to the IP addresses for us, as we can see here. And they also added some basic timing information to the ticket, providing a rough estimate of the time span to be analyzed. Below this manually added information, we can already see the first insights provided by the NetFabric intelligence engine. NetFabric maintains an internal representation of your network that is periodically updated with configuration data, and network agents enriching it with flow observation data to enhance the information density. As a result, the intelligence engine indicates for the traffic flow from the API server to the service server already 3 different types of events that can be of interest to you. These include path changes, due to failing links or changes in the routing decisions, unhealthy links, due to malfunctioning hardware, and path anomalies, due to traffic observations not matching the expected path inferred by the intelligence engine. We cover path changes and unhealthy links in other demos. You can find them linked below. With one path anomaly being observed, we have a starting point for our investigation. By simply following the anomaly, NetFabric displays the state of the entire network, allowing you to visually grasp complex network configurations. Underneath the network topology, a timeline of the observed path changes from flow observations and the timeline of expected paths based on the routing model are provided to you by the NetFabric intelligence engine. Shifting the focus back to the graph, we focus on the orange path. Drawn on top of the entire network topology, colored in blue, the orange path is the observed path of our flow from the customer source to a destination. These observations are made by the network devices with protocols such as sFlow. The engine enhanced the flow information in addition with the forwarding behavior of the individual devices to increase the information density and show used links. But as you might have noticed, the orange path is extended by the grey path with a dashed line style. This path is the expected forwarding path from the source to the destination. NetFabric evaluates the device configurations and then uses this information to present to you the expected forwarding behavior. Instead of manually running trace routes and investigating forwarding tables, NetFabric instantly shows the expected versus the actual path to you. With the visualization, we can also immediately pinpoint the problem. The observed path in orange does not reach the same destination as the expected path in grey, meaning the traffic does indeed not reach the destination as mentioned in the ticket. In more detail, the traffic does not pass the router at node 14. But what exactly is the issue? Many are plausible, just to mention a few. The outgoing link is down and no traffic can pass. There is a routing error causing traffic to be misdirected and then being eventually dropped, or the device blocks the traffic due to its configuration. First, we assess the status of the link. To determine whether the link is functioning correctly, we utilize NetFabric's Link Health tool, which is explored in more detail in a separate video linked below. Activating the basic health check, we identify several unhealthy links. But switching over to the intelligent analysis, we correct the previous findings and observe no unhealthy links along our path, allowing us to rule out failing links as the cause of the unreachable services. Another possibility is a misconfiguration in the routing behavior. However, this can be ruled out too, as NetFabric analysis shows the forwarding path reaching the destination as expected. We've observed that the links are healthy and that the route actually leads to the customer's target device. Hence, we suspect a device misconfiguration on the last device of the observed path. Traffic being dropped at the device could be due to an ACL. Leveraging NetFabric's ACL analysis, you can evaluate the ACLs on the entire path. We now see the overview of the ACL analysis. First of all, our selected path is shown at the top. Below that, the pre-populated details of our customer's flow according to the ticket are given. These options allow for very specific checks, since many network device vendors allow for ACL definitions with further details than only the source and destination IP address. Since we only have these IP addresses from the ticket, we leave the other parameters at the value any, covering all possible inputs. Based on these inputs, the ACL analysis evaluates the state of the ACLs on each device along the given path. Leveraging the computed forwarding behavior by the NetFabric intelligence engine, only interface-specific ACLs are applied. Traditionally, this process would require manually identifying the exact path and extracting the relevant interfaces and their ACLs from each device, a time-consuming task done by NetFabric in a single click. Moving to the results section, we see our path with the devices as nodes in two colors, red and green, red indicating that an issue was found. Inspecting node 14, we find more details about the reason for the given status. The flow was blocked by the ACL with the name IP tables port BB1-1 ingress. Furthermore, we also presented with the exact line that was matched. So, we found the reason the traffic of our customer does not reach the data center. Packets are dropped at the router BB1.5 due to an ACL line that drops all traffic going to the subnet where the customer service is located. Again, NetFabric saves you time. Unlike manual analysis, which requires you to interpret ACLs yourself, NetFabric automates this process, precisely identifying the relevant line amongst hundreds, while eliminating the risk of human error in rule comprehension. Now, with the issue being identified, we can forward our findings to the network engineers such that they can apply a fix. Let's summarize. In this demo, we've seen how the NetFabric intelligence engine empowers you to see the full picture by connecting and correlating multiple data sources for smarter troubleshooting, instantly detect and pinpoint ACL misconfigurations, reduce resolution times and improve network performance. By building a deep understanding of your network and automating tedious troubleshooting steps, NetFabric enables you to focus on what truly matters, keeping your network running smoothly. Want to learn more about our advanced log analysis capabilities? Click the link below.